Hi, my name's Don, and I primarily design and test antennas for a living. And I'm here today to try to explain to you basically a little bit about how antennas work. So the first thing I want to start out with is the antenna wire, and we call it coaxial cable. So the first thing we're going to talk about is what is not coaxial cable. This is just normal power cable. You notice that the lines are parallel to each other. This is coaxial cable. You'll notice that there's a shield on the outside, and then there's an insulator, and then there's a center conductor. The center conductor is actually what runs the power to the antenna. The reason that this is important is how an antenna works. So if you have two pieces of wire side by side, you have current flow in this direction and current flow in that direction. The current flows cancel each other out. If you have a piece of coaxial cable, this is actually grounded on the outside, and the current flows in this direction and the current flows in that direction on the inside, and the currents cancel each other out. How we get an antenna to work and actually radiate power is to change that. So to change that, we want to transmit that power out into the air. So once again, you have two pieces of wire, and you have current flow in this direction and current flow in that direction. A simple dipole antenna, like you put on your FM stereo at home, is just when you take this wire and split it off over to this direction and split it off over to this direction. And now I still have current flow in this direction, and I still have current flow in this direction. But if you notice, now the current flows in the same direction across this plane. And that allows us to generate RF energy that leaves like this and can be received as well. So if you have two pieces of wire side by side, the electromagnetic energy that is generated from current flow cancel each other out. So if I have a wire here and I have a wire here, this one we'll call it positive and this one we'll call negative. Because this one's positive and this one's negative, you can't get any energy to radiate out because they cancel each other out. I think that's pretty simple. But if I take and I separate these two wires like this, so this is still my feed point down here, and I have current flow in this direction and in this direction, and I have current flow in this direction and in this direction. But every time you have current flow, you also have electromagnetic energy. So now because I have current flow in the same direction across this plane, now I have an energy field that looks like this. I have a high current point here and a low current point here, but a high voltage point here. And when that high voltage point hits there, all that electromagnetic energy jumps off the wire and radiates out into space. That's basically how an antenna works. Most antennas act very similar to a dipole antenna, and that's what this is. And remember, on a dipole antenna, you have radiated energy on both sides. How does an antenna receive energy? Well, like on a cell tower is radiating energy, just like our antenna here was radiating energy out. Well, the radiated energy also can be received by this same antenna. So the antenna captures that energy and then transfers it down to our feed point, so we can run into an amplifier, or maybe you just plug it straight into your stereo system, or on a car stereo, you plug it into the back of the car stereo, and they all act very similarly.